Hello, welcome back. So today we're going to continue on with some proofs. Today it's going to involve angles. So we still have all of our old properties of equality and congruence that we used before. We're going to add some new ones today. So nothing you need to fill in, but there's also a definition of congruence for angles. So if two angles are equal, they're congruent. There's definition of an angle bisector. So if you have an angle bisector, it means it splits the angle into two equal parts. Complementary means the sum is 90. Supplementary means the sum is 180. Perpendicular means that the lines form right or 90-degree angles. Definition of a right angle is that it is 90 degrees. Just like we had the segment addition postulate, there's also an angle addition postulate. So as you can see in that picture, if measure of ABD plus DBC is equal to the entire thing. So get my pen on here. So this angle plus this angle equals the entire thing. If two angles are vertical, then they are congruent. So remember, vertical is like this and this. Complement theorem. If two angles form a right angle, then they are complementary. So meaning they add up to 90. Supplement. If two angles form a linear pair, then they are supplementary. So just remember, if we have two angles like this, they add up to 180. And for the complement, if we have two angles like this, and we know the whole thing is 90, they add up to 90. Congruent complements theorem. If A is complementary to B and C is complementary to B, then A is congruent to C. So to draw you a little picture, say that's A and B, and then B and C. So in that case, because they're both complementary to the same angle, they have to be equal. So A has to equal C. Same thing goes for supplementary. So if we have A and C, and then we have B and C is the same angle, then A has to equal B. So those are our new theorems, postulates, properties, definitions. So just like we've been doing on the previous sections, we're going to do some practice just identifying which definition, theorem, or postulate applies. So if A is a right angle, then the measure of angle A is 90. So that goes back to your definition of a right angle. I'm just going to abbreviate angle. If X is supplementary to Y and X is supplementary to Z, then Y equals Z. So that is that very last one we just talked about where I drew that diagram. That is the congruent supplements theorem. Okay, if it's got a picture of vertical angles, then angle 1 is congruent to angle 2. So that would be our vertical angles. And that's considered a theorem. I'm just going to put a T for theorem. If P plus Q equals 90, then P and Q are complementary. So that is going to be our complement theorem. If M and N form a right angle, then M and N are complementary. So that's going to be, because they form a right angle, so that's the complement theorem. which means I think I messed up 4. 4 is actually definition of a complement. So you just have to be careful about that notation. So it's not the theorem, it's complementary definition on 4. Number 6, so it shows us a diagram. If L is perpendicular to M, then angle 1 is a right angle. So that's going to be our definition of perpendicular, because it says perpendicular lines form right angles. Remember this symbol here, that means perpendicular. Okay, if W and X are supplementary, then their sum is equal to 180. So that's going to be our definition, supplementary angles. If angle L is complementary to angle M and angle N is complementary to angle M, then L is congruent to N. So that is our second to last theorem here, the congruent complements theorem. If angle A and angle B form a linear pair, then A and B are supplementary. So that is our supplement theorem. If angle N and angle P are complementary, then angle N plus angle P is equal to 90 degrees. So that's our definition of complementary angles. Okay, given this diagram, JKM plus MKL is JKL. So that's saying this angle plus this angle equals the entire thing. So that's angle addition. Okay, if angle R equals angle S, then angle R is congruent to angle S. So that's our definition of congruence. Perfect. So that is our practice identifying the theorems. Now we're going to practice some of the proofs. So everyone's favorite part, right? Doing the proofs. All right, so we have 9 proofs to go through. So I'm going to do all except for 3 of them with you. And I'm going to try to leave you the easier ones to try. So I'm going to have you try 1, 4, and 3. 1, 3, 4. Everything else I'll do with you. And remember, the answer key is posted on Classroom under Unit 2 Notes key. All right, here we go. So starting out with number 2, they tell us angle 2 is congruent to angle 3. So I'm just going to mark that for myself. And angle 1 and angle 2 form a linear pair. So we start off with our given. So then they said, okay, if angle 2 is congruent to angle 3, that means their measures are equal. That's just definition of congruence. So just to clarify, when you're saying congruent, you're referring to like an angle or a segment. When you're saying the 2 things are equal, it has to be a measure. So that's why they use the equal sign with the measure of angle 2 and measure of angle 3. Angle 1 and angle 2 form a linear pair. That was given to us. Oops. Given. Angle 1 and angle 2 are supplementary. So that is just going to be definition of supplementary. If they're a linear pair, they've got to be supplementary. Okay, so then they say, well, if we know that, then we know that 1 plus 2 equals 180. So again, that's definition of supplementary. So I know it seems kind of annoying that you have to write out every little thought, but that's how these proofs work. You have to assume the person you're explaining this to doesn't know anything, and you have to go step by step by step. So then they say, well, then I know 1 and 3 is 180. So how they got that is they knew 2 equals 3. So they just substituted 2 with 3. So that'd be substitution. So then they said, well, then we know 1 and 3 are supplementary since they add up to 180. So that's just definition of supplementary. Awesome, first one is done. So let's move over here. So 4, I'm gonna let you try, but we'll do 5. So 5, they tell us RSU is congruent to VST. So let's mark that. So the first statement's given. Then they say if the angles are equal, then if the angles are congruent, then the measures are equal. So that's definition of congruence. Then they said, all right, well, I know RSU plus USV equals the entire angle RSV. So adding the two together equals the sum of the two pieces, so that's angle addition. Then they said, okay, so then that means I know that the measure of VST plus the measure of UST equals UST. So let's look at that. So now they're just using VST, so the other side plus USV equals TSU or UST. So yeah, that's also angle addition. It's just a different set of angles. Okay, so then they said, well, RSU plus USV has to equal UST. So let's think about how they got that. So we have that expression here and here. Here it equaled RSV. Now they're saying it equals UST. So we have to think about how they got from there to there. So think about if they could have used substitution, what could they have done? So it looks like they used the fact that RSU is equal to VST, so they did substitute. They replaced VST with RSU here, and then they just left USV alone. So they just substituted this for this because they knew that in line 2. So that would be a substitution. Then they said, well, if those two angles are equal to each other, then their measures are going to have to be equal to each other. So on that one, they're using the transitive property, or you could do substitution. So because they already identified that UST is equal to RSV by lines 3 and lines 5. So notice how the left side is equal to each other. So that's how we knew that. So then now they're saying, well, if we know that, and we knew RSU is equal to VST in step 2, then we would have to know RSV is equal to UST. So a lot of stuff going on there. I know that's a lot to process. I would take substitution or transitive, because if you look all the way back to line 2, you could call that transitive. So either one. So I'm not going to be real picky about the substitution transitive thing on problems like that, because I know that you could just be looking at the lines above, or you could be looking all the way from the beginning. Okay, continuing on. So now they're saying, well, if their measures are equal, then they have to be congruent. So that's just definition of congruence. Awesome, another one done. So let's look at 6. So 6 tells us 1 and 2 are complementary and 3 and 4 are complementary. So those first two are given. So then they say 1 plus 2 has to be 90. That's definition of complementary. I'm just going to abbreviate. 3 plus 4 is 90. Same thing, definition of complementary. Then they say 2 and 3 are congruent. So notice how those are vertical angles, and we know vertical angles are congruent. So we'd say vertical angles. They're saying, well, that means 2 equals 3. The measures of 2 equals the measure of 3. So that's definition of congruence. Okay, so now they're saying 1 plus 2 equals 3 plus 4. So how they're getting that is we know 1 plus 2 is 90 and 3 plus 4 is 90. So that would be by substitution. So then they're saying, okay, if I know that, then I know 1 plus 3 equals 3 plus 4. So notice they made a change here. They replaced 2 with 3. So that's substitution, or if you want to go all the way back and look at lines 3 and 4, that'd be transitive. So again, either one. So they said, well, that means 1 equals 4. So they subtracted measure of angle 3 on both sides. So that's subtraction. Then they said, okay, well, if measure of 1 equals measure of 4, then they have to be congruent. So that's definition of congruence. All right, that is that page. So we have a few more to do on the next page. So let's take a look at those. Bear with me. I know these are a little bit tedious. Proofs are not my favorite part of this class either. I promise we won't be doing these forever. They go away after a few chapters. So the whole second semester, you won't have to deal with this. All right, so these are going to be a little tougher. They're going to ask us to fill in some missing stuff. So let's give it a shot. So the first one, they tell you angle 1 and angle 4 are congruent. That's given. Then they give you the next step. They want the reason to be definition of congruence. So I would go measure of angle 1 equals measure of angle 4. So just like we've done on a lot of the ones on the previous page. Then they want another given. So the given they're missing is angle 4 and angle 5 form a linear pair. So then they said, okay, then 4 and 5 are supplementary. So that'd be definition of supplementary. Then they want another definition of supplementary. So I know that that means the measure of angle 4 plus the measure of angle 5 equals 180. Okay. Then they use substitution, and they're trying to say 1 and 5 are supplementary. So because back in step 2 here, I know 1 is equal to 4. I'm going to replace 4 with 1. And that would be by substitution. So then I could say, well, if their measures add up to 180, they're supplementary. So that's definition of supplementary. Okay, and eventually we're working you up to it. So yesterday, all the statements were filled for you. Today, we're leaving some of them blank. But then eventually, we're going to work you up to doing them from scratch with no statements or reasons. Just do know that there are multiple ways to do a lot of these proofs. Okay, number 8. 1 and 2 are a linear pair. So that's given. Then they wanted us to use the supplement theorem. So if they're a linear pair, then we know that they add up to 180. So we're going to want to fill in something that has to do with that. So we could just say angle 1 and angle 2 are supplements. Okay, then they have another given. So the measure of angle 2 plus the measure of angle 3 equals 180. It's also given. And then they want the definition of supplementary angles. So then I would say angle 2 and angle 3 are supplementary. Okay, so then we know 1 and 2 are supplementary and 2 and 3 are supplementary. So then we're saying 1 has to be congruent to 3. So this one gets a little bit tricky. So we have to think back to those theorems on the previous page. And let me see if I can easily get back to that. Being a little bit of a pain today. Okay, cool, I did. So this goes back to this one here, the congruent supplements theorem. So just be really careful on the wording. Congruent supplements theorem. So that was where I drew that picture where you had like A and C were linear pairs and A and B were linear pairs. So then B and C had to be equal to each other. This is the exact same thing. So always go back and refer to that sheet if you're stuck. If it's the definition of supplementary, if it's that congruent supplements theorem, or if it's the supplement theorem, just go back and check the wording. Awesome, done with number 8. So number 9, AB is perpendicular to BC, that's given. So they said, well, if they're perpendicular, then that has to be a right angle. So that's the definition of perpendicular. So the definition of a right angle means it is equal to 90. So I'm going to say measure of angle ABC equals 90. So then they said 1 plus 3 equals ABC. 1 plus 3 equals this whole angle. Okay, that makes sense. That's angle addition. So then they say 1 plus 3 equals 90. So why would that equal 90? Well, because those add up to ABC, and we know that ABC is a right angle. So that's going to be because of definition of complementary angles, because 1 and 3 are complementary. My pen just went out. There we go. Okay, so then it looks like they want us to use definition again. So I would just say 1 and 3 are complements. And then they finally use that second given, so angle 2 and angle 3 are complements. And then they're saying, well, then angle 1 is congruent to angle 2. So this is just like the proof in number 8. So notice how those last 3 lines are the same. It's just complementary instead of supplementary. So if you go back and look at those theorems, this one's the congruent complement instead of congruent supplement theorem. So if 1 is complementary to 3 and 2 is complementary to 3, then that means 1 and 2 are the same angle. Awesome, guys. That was a tough one. Good job. Go ahead and give those 2 or 3, actually, that I assigned you a try and check your answers on the key for Unit 2 in Classroom. That wraps up Chapter 2. We'll see you next time for Chapter 3.